Flue gas heat recovery explained. My name is Hart, and in today's video I'm back at the National Gas Centre for Excellence, and I'm back with Michael again, and Michael's going to go through flue gas heat recovery. We was asked a question in the group, the Alan Hart group, on Facebook, and this is what this video is about today. So we're going to go through, or Michael's going to go through flue gas heat recovery, explain how it works. If you do have any questions, please put them in comments below. As always, if you could put a thumbs up on the video, really appreciate that as well. So yeah, let's have a look at this. Just before we go over to Michael, I have managed to get hold of a flue heat recovery system from the carer. So what I'm going to do at the end of this video, so watch to the end, after Michael's shown us and drawn it on board, what I'm going to do is I'm going to take this one apart, I'll cut it up with grinder, and then hopefully once Michael's told you, shown you on board, also Michael's going to show you on an ATAG boiler, because ATAG got them built in. But after all that, at the very end, we'll cut this up and we'll have a look inside, and then hopefully that'll help you understand. As always, a lot of time and effort goes into these videos, as hopefully you will see. We what I try and do here to help you understand. So thumbs up and comment is a must. Thanks very much. Let's go over to Michael.
Thank you, Alan. We've been asked by Ivan Goodall to do a video on flue gas heat recovery and look at it on a unit, and go into the theory of how flue gas heat recovery works. If we look at a normal boiler, a standard combi boiler, what we generally have, and this is a simplified drawing, but you've got your cold water goes in, goes through a heat exchanger, a plate-to-plate heat exchanger, and comes out hot. Now, the heat exchanger is indirectly heated by the main heat exchanger, so your heating circuit within the boiler. But what we can do is we can add flue gas heat recovery units to boilers, to combi boilers, and what that will do is significantly increase the efficiency of the hot water circuit. So if we were to draw, a flue gas heat recovery unit on this unit, typically what we're used to seeing is something similar to this. So you have an additional box on top of the flue, which then has another flue coming off the top of it. Now inside the flue gas heat recovery unit, that's another heat exchanger, and what it does is we take the cold feed from the mains, and usually it can run to the back of the unit, or it can run up, multitude of different entry points and piping options. But basically, the cold water goes up into the flue gas heat recovery unit, absorbs the heat, the excess heat from the flue, and then we get much warmer water coming out, which we will then take into our cold main. Now, Baxi claim that a flue gas heat recovery unit can save you between 37 and 50% on your hot water, which is astounding, really. Again, that's on Baxi's figures. But so that's the theory of how it works. Where we would normally lose a lot of heat out of the flue, we reuse that heat and use it to heat up the cold mains coming into the boiler, and therefore there's less work for the boiler to do to get the heat, to get the water to temperature quicker. So the benefits of it are higher efficiency. You've got lower temperatures of your flue gases coming out, so you're losing less heat. So you could argue that creates less of a nuisance plume. You've also, a lot of manufacturers state that you get better hot water flow rates. Now, whilst it's a bit of a play on words, really, it won't give you a better flow rate. What it'll do is it will give you a better flow rate at a 35 degree, at a higher temperature, a 35 degree rise. So that's where that comes in. But ultimately, a really good unit, a really good bit of kit. So flue gas heat recovery units are generally on top of the boiler, on top of the existing flue. However, some manufacturers like ATAG, for example, have gone one step further, actually built it into the boiler itself. So what we're going to do now is we're going to pop across, we're going to have a look at an ATAG Economiser and have a look at how the flue gas heat recovery unit is built into the boiler and how that would work. So here we've got an ATAG Economiser and this boiler has built-in flue gas heat recovery. So I've already taken the screws off the top, so what I'll do is I'll just take the case off, pop it to one side, and I'll just pull this down. So now what we've got is where usually our boiler cold main coming in would come straight in, go through a flow turbine, whatever it may be, and then go into the plate heat exchanger. We've actually got a situation here on the economizer where we have a flue gas heat recovery unit here, as opposed to it being on top of the boiler itself. So the boiler will fire up for hot water, the cold water will come through. Rather than exhausting the excess flue gases through the flue directly, what it will do is it will recirculate it through this heat exchanger first, before then it being expelled through the main flue. Now, the water comes in here, and then it runs through a little manifold through some flexible pipe connectors to this flue gas heat recovery unit, and then it goes back into the plate heat exchanger. So it's very, it's quite, there's very little system resistance in this case. And yeah, so this boiler is able to give you, even on the 27 kilowatt model, this boiler can give you 12.6 litres of hot water at 35 degree rise, which is really good for this in this kind of bracket. So yeah, that's how the flue gas heat recovery unit works when it's built into the boiler itself. I hope that makes sense, and I hope that that answers some of the questions that we've had regarding flue gas heat recovery and how it works.
Thank you very much for that, Michael. Back to the boiler now. So this is actually an Ideal Vogue boiler. So this doesn't fit with this boiler. Ideal do a boiler. They do an Ideal Logic where it's got a flue heat recovery system on top. So they do a system for that. So what Michael will tell you there, what this is doing, when your boiler's running, your boiler, the flue gases, obviously there's some temperature in the flue gases, and what we're trying to do, we're trying to take as much of that energy as possible to save money on your gas bills, which is the main reason why people would do it. But another reason is it'll make boiler last longer, because boiler's not working quite as hard. It might not make a massive difference, but it will make some difference. One of the reasons I believe they didn't catch on very well is because they're quite expensive. But I, in my personal view, these should be on every boiler. What I'm going to do now, we'll take this off here. I'm going to take it all apart. We'll cut it up. We'll have a real good look inside it, and you can see how it all works. But as always, if you've got any questions on any of this, just ask in comments below, and I'll try my best to answer as many of the questions as I possibly can. I don't always get round to all questions, and I do sometimes get some nasty comments saying, well, you haven't responded. I do get hundreds and hundreds of messages, if I'm honest with you, but I do try my best to answer every single one if I can. So as I say, please put a comment below, and yeah, let's take this off, let's have a look inside it. So I'll just remove this off top of here. All I've done with this is I just sat it on it, just to show you really. Normally it'd be screwed onto the wall. So this was a really good design from the carer, really. What you've got your cold there and your hot there. So your cold mains comes into here, as we've shown you already, goes round this heat exchanger in here, and then it comes out here as warm air. So it might only be a few degrees. It might raise it by maybe 2 or 3 degrees, not quite sure, I'd have to look at technical data. But then what that does then is it goes into what would have been the cold feed, if you like, into the combi boiler. And then instead of the temperature of the water, say the water's normally 10 degrees going in, the water might be 13, 14, 15 degrees going in. So the boiler then doesn't need to heat the water quite as hot to achieve the same results. So that means it's going to save you money on your gas bills. Also, as I've said already, it's going to reduce the stress on the boiler, if you like. Anyway, I'm babbling on at her. What I'll do now, I'll just take this apart. Just got some screws at the top, so I'll take this apart and we'll have a look inside it. Right, okay, so I've taken all screws out of this. So this is like a plastic cover round here. And how this would work on top of the boiler, if you imagine that's the top of the boiler there, you've got your flue gases going through here, and then you've got your air intake coming back here. So that's how that part of it would work. So on this outside bit here would be the air intake, so that's the air coming from outside, and again on the top that's the air intake. But then this middle bit, that's where your flue gases would be. So, trying to explain this best way I can, dyslexic plumber, trying to train people, if you like. Please put a comment below, should I get a job in training? So flue gas is going through there, and as we look on the other side, what you've got there, you've got a big massive coil of pipes in there. So looking at that pipe, what you've got the cold, so from your cold mains coming into here, goes around here, into here, all around this coil in here, so very simple, and it's just mixing with the flue gases, and it's taking as much of the heat out of that flue gas as possible. It's going then back out of here, back out of there, and then this hot one here is then going back to the boiler, and it's going back into the cold inlet into the boiler. So what would be normally your cold feeding inside your boiler, and then obviously it goes to your plate heat exchanger, as Michael said earlier. One little thing, I don't know if it makes much difference or not, just what I noticed is, if you imagine this part of it is the cold air coming in from outside, if you like. This pipe here, there might be a little bit of a, I don't know if it'll make much difference, but that pipe there isn't lagged. So as it's taken some of the hot flue gases and it's going back into the boiler, that could maybe reduce a little bit of efficiency. So if that were adapted, maybe, and I might be thinking of this totally wrong, so somebody please put a comment below if you know what I'm babbling on about. But I would say that there should maybe have some lagging on, just to protect that, because that's now, you would hope, has taken as much of the flue gas temperature as possible, and that's going now back into the boiler. So by it not being lagged there, this bit that is the jacket of cold air, if you like, cold from the outside that's feeding the boiler, the cold air that's going into the boiler, would cool that down a little bit. Let me know what you think. But that's how it works anyway. I hope I've explained that well enough for you to understand. I do try my best, try and cut stuff up, try and take stuff apart. As I say, I'm dyslexic and I struggle with things that are written down. So I try and take stuff apart and understand it. So yeah, hope that's been of some use. I have got another little clip. I've got a few clips now. I've got a clip from a Johnson and Starley boiler, so I'll show you that clip. And I've also got one from when we went to install a live or whatever it was, one of the shows many years ago, and that's just a little clip. But I'm not going to come back into this video now. I'll just show you them clips. And thanks for watching. As always, if you can put a comment below, I know I'll keep babbling on about that, or keep nagging and asking you to do that. It's really important. Also, if you can put some comments and let me know what videos you would like me to do, just so that I'm not just doing videos that nobody wants to see. Obviously this video was a request today. Yeah, thumbs up, subscribe, share as well. Come and join us on Facebook as well now, because I've got my own group. I was posting my videos in different groups, and sometimes I felt a little bit uncomfortable posting the videos in different groups, so I thought, you know what I'm going to do? I'll set my own group up in my name, and it'll be about what I'm doing. So if I'm going to do charity work, it'll be my charity work. If I'm going to be doing videos, it'll be my videos. So just everything to do with me, if you like, or my stuff, what I do, and also the people that help and support as well are in there. So yeah, come and join us on Facebook as well. Yeah, let's have a look at these clips. Thanks for watching, and see you on the next video. And this is a Johnson & Starley, and how they achieve passive flue gas heat recovery is they have the primary heat exchanger at the start of it, and then they have the secondary section of it, and then at the very back they have where the cold mains comes in. So the cold mains comes in from the tap, goes round the coil, and then that part of it then connects to the plate heat exchanger, and then it would heat as normal. And then the flue gases are rerouted, so they have to go through where that coil was, and then it just goes back up and out of the flue as normal. So that's just another example of using more of your energy with a flue gas heat recovery system. If you feel one example's better than another, please put a comment below. Let me know which one you like best.
How are we doing, everyone? Jason Lewis from ATAG. Alan's asked me to have a quick run through of our nice lit up demo boiler with a cutaway. All seen the heat exchanger. You can see there the cutaway and the tubes, the size of the tubes. Obviously your ceramic burner where the air gasture mixture comes in. One of the interesting ones is the air to water heat exchanger just in the side here. So as you can see, that's where our 3 kilowatts of free heat from the flue recovery is gained. Air to water heat exchanger, not water to water, so shouldn't have any problems with corrosion. And again, as you can see inside, it's all brass, all stainless steel pipes except for the flexes for the secondary heat exchanger.